All right, let's dive in. Today we're talking about something that is quite literally inside every single one of us: blood. We all know it's this life-sustaining river flowing through our veins, right? But what's in that river? And how does it pull off all these incredible life-saving jobs every single second of the day? Well, that's exactly what we're here to break down.
So let's start with a simple question. Have you ever really thought about what's packed inside just one single drop of your blood? I mean, it's not just some simple red liquid, it's more like a bustling city, a whole microscopic metropolis, just packed with specialized cells and vital compounds, and every single one has a critical job to do.
So, right off the bat, here's the top-level breakdown. Your blood is basically two main things. A little more than half of it, about 55%, is this yellowish liquid called plasma. The rest, that other 45%, that's what we call the cellular elements. And yeah, that's where you'll find all the famous players, the red and white blood cells.
Okay, so let's tackle that majority player first, the plasma. The best way to think about it is as the river itself. It's the liquid highway that carries absolutely everything else all around your body.
And at its heart, plasma is mostly water. We're talking like 90% water. But it's that other 10% that's the real magic. That's what turns it from just H2O into this incredible, life-giving fluid, just jam-packed with a cargo of proteins, hormones, and all the nutrients your body needs.
And just look at the variety of stuff it's hauling around. You've got these amazing proteins like albumin, which is a master at controlling your fluid pressure, and fibrinogen, which we'll see later, is absolutely crucial for clotting. And at the same time, it's delivering sugars and fats from your lunch, electrolytes to keep your body's chemistry in balance, and hormones that are basically the body's text messaging system. Okay, so if plasma is the river, what about the cargo ships? I mean, how does the body solve this huge logistical problem of getting oxygen to literally trillions of cells? Well, for that, it has a highly specialized, super efficient delivery service, the red blood cells.
These guys, their technical name is erythrocytes, are by far the most numerous cells in your blood. And they have one incredibly important job: transport oxygen. That's it. And the way they do it is by using a special protein that's packed inside them called hemoglobin. Hemoglobin is the real key here. Now, you can't just build this massive delivery fleet out of thin air. It's a really precise operation. It starts with a signal, a hormone from the kidneys that basically says, go. Then you need the raw materials. You absolutely need iron to build the actual hemoglobin molecules. And you need both folate and vitamin B12 for the cells to divide and mature properly. If you're short on any of these, you're going to have a problem. And that can lead to different kinds of anemia.
And that brings up a really practical question, right? How do doctors actually know if this delivery fleet is in good shape? Well, that's what blood tests are for. They give us a kind of report card on our red blood cells and their all-important ability to carry oxygen.
So let's peek at a couple of these key metrics. You've got MCV, that's mean corpuscular volume, which is just a fancy way of saying the average size of your red blood cells. If they're too small, that could point to microcytic anemia, often from not having enough iron. Too big? That's called macrocytic anemia, and it might make a doctor think about a B12 or folate issue. Then there's MCH. This one's about the average weight of hemoglobin in each cell. If that number's low, it suggests hypochromic anemia, which basically just means your cells are looking pale because they aren't packing enough hemoglobin.
So, a delivery service is obviously vital. But that river of life is also a potential highway for invaders. We're talking bacteria, viruses, you name it. So to patrol these waterways and defend the entire body, blood has its own highly specialized military, the white blood cells. Their official name is leukocytes, and these cells are the absolute bedrock of your immune system. But unlike the red blood cells, they aren't all the same. Not at all. They're actually a really diverse army made up of different kinds of soldiers, and each one has a very specific and unique role in protecting you. You can think of them like different units in the military. You've got your neutrophils. They're the first responders, the grunts that swarm an infection site to just destroy bacteria. Then you have the lymphocytes. These are the special ops, your T cells and B cells that have memory and can hunt down specific enemies. Monocytes are the cleanup crew. They turn into these big eaters called macrophages that just engulf debris and invaders. Eosinophils are your anti-parasite specialists. And finally, basophils are the alarm system, releasing histamine during things like allergic reactions. Okay, so we've got delivery and defense covered. But what happens when the system itself is breached? You get a cut. You can't just wait around for a slow repair process. You need an emergency crew that gets there in seconds. And that is exactly where platelets come in.
The formal name for this whole process is hemostasis, and it's just this remarkable, absolutely life-saving ability the body has to instantly plug a leak at an injury site, preventing what would otherwise be a total disaster.
And it all happens in this incredible rapid-fire sequence. First, the blood vessel that's been injured immediately squeezes shut to slow down the flow of blood. Then, platelets that are floating by get the signal, they rush to the scene, they get all sticky, and they start piling on top of each other to form a temporary plug. And that's the trigger for the final step, coagulation. This last phase is just a brilliant domino effect of protein activations. Remember that fibrinogen protein we talked about back in the plasma? Well, now it gets converted into these sticky threads called fibrin, which form this incredibly strong mesh all over the platelet plug. And that creates a really durable, stable clot that seals the leak for good. It's an amazing piece of engineering. So all these systems, delivery, defense, repair, they're pretty much universal in all of us. But our blood itself isn't all identical. See, each of us has a kind of unique ID card, and it's written right there on the surface of our red blood cells, and we call that our blood type. So how does this ID card work? Well, it's all about these protein markers called antigens. Just think of them as little flags waving from the surface of your red blood cells. And these flags basically tell your immune system, hey, I belong here, I'm friendly. Whether you have certain flags or not is what determines your blood group. Now, in the most famous system, the ABO system, it works like this. If you have the A flag, the antigen, you're type A, and your body will automatically have antibodies against B. If you have the B antigen, you're type B, and you have anti-A antibodies. Type AB, you've got both flags, so you have no antibodies, which makes you the universal recipient. And type O has no flags at all, which makes them the universal donor, but they have antibodies against both A and B.
But here's a really crucial difference you got to know between the ABO system and that other big one, the Rh system, the positive or negative part. Those anti-A and anti-B antibodies, they're just naturally there from early on in life. But with the Rh system, it's different. A person with Rh-negative blood will only develop anti-Rh antibodies after they've been exposed to Rh-positive blood. And that little detail is hugely important in things like blood transfusions and pregnancy.
And when you take the two main letters from the ABO system and you combine them with the plus or minus from the Rh system, you get the 8 common blood types that we're all familiar with. Everything from O negative, which is that universal donor so prized in emergencies, all the way to AB positive, the universal recipient. It's this amazing diversity that makes blood donation both a science and a constant life-saving challenge for hospitals everywhere. When you really step back and look at the whole thing, blood is so much more than just a liquid. It's this perfectly unified, incredible system where every single tiny component, from the plasma river to the red cell delivery fleet to the platelet repair crew, has a totally critical, life-sustaining mission. At the end of the day, your blood is like a flowing record of your health, your history, and your body's nonstop daily fight for survival. It tells an absolutely incredible story, and it's a story that's completely unique to you. So the only question left is, what will you learn from yours?